Hello everyone, my name is Augusto Borges. I'm BIM Specialist at MRV. Today I will show how we have optimized our construction CapEx using Autodesk Platform Services to solve a critical business challenge. So let me start by giving you some context about us. We are the largest construction company in the housing sector in Brazil, delivering over 40,000 units per year with 500 projects running simultaneously. With this scale of operation, optimization is not just beneficial, it is essential for our business success. So to achieve this optimization, our construction method is fundamental to understanding the challenge. So we build using concrete walls with aluminum formwork. This method allows us to concrete 2 apartments per day with just one set of formwork parts, as you can see in this video. And the fundamental factor of this method is high repeatability. But the formwork requires consistent dimensions to be cost effective, which led us to our main challenge. So we need to maximize formwork reuse by optimizing project sequences. Our target is 700 cycles per formwork set, and when modifications are required, costs can reach $300 per square meter. The critical question became how to compare dimensional characteristics across 500 projects to ensure the best project sequence for formwork reuse. So our solution is the SKU strategy, adapting the stop keeping unit concept from logistics to construction. We actually encode entire buildings into alphanumeric strings, capturing formwork critical dimensions. For example, in orange, HU8 indicates the apartments per floor, LE274 encodes the stair width, and CT4252 represents the total length. However, the scale made manual processes unfeasible. With 500 active projects and over 100 professionals writing SKUs manually, it was nearly impossible to ensure consistency of measurements and required at least 3 hours of analysis per project. So this is where we turned to Revit API and Autodesk Platform Service to develop an automated solution. So let me walk you through our technical workflow. We start with Revit models across all projects. These models go through an automated analysis process that extracts SKUs from each building. This data is stored in ACC. From there, we create analytical dashboards that enable data-driven decisions about resource allocation. Beyond time saving, we have achieved high precision and significantly reduced CapEx through optimized formwork utilization. So let's take a look in our technical implementation in more detail that works with 6 steps. First, using Data Management API, the project's main model is located and opened in Revit. Once opened, the automation evaluates qualitativity, quantitativity, and mainly geometric data from all the files and generates the SKU code for each building. Still, with the same automation, it creates a hierarchy of buildings with SKUs in ACC's location service with its web API. Then, all locations of all projects and everything in our hub are extracted via Data Connector API to our data lake. So with the data now in our data lake, we have built dashboards that provide a holistic view, enabling cross-project analysis. And the last step is the issues propagation. So when construction teams identify a problem with a specific building type, the system identifies all projects with the same SQ code. For example, a formwork issue discovered in São Paulo triggers design reviews for identical buildings across the country. This is our complete workflow in detail with all features. Now about our results. In this video, you can see the whole process. First, the extraction running in Revit after selection some projects. Next, the data made available in ACC's location service with SQ and hierarchy of buildings. And finally, the results dashboards in Power BI. This process has already run on more than 600 projects and generated more than 1,200 SQs. Our database contains over 40,000 standardized building characteristics, all extracted consistently. And most importantly, we have optimized formwork sequences across our portfolio. Now, let me share the main technical challenge we faced when implementing the automated analysis system. A key challenge was handling buildings models created with different standards over the years. We developed algorithms focusing on fundamental geometries rather than specific components and element properties indeed. Our approach detects patterns through indirect model data analysis, adapting to various modeling scenarios. The result is 92% of all models analyzed automatically, regardless of when or how they were created. So to illustrate what I'm saying, consider our star length algorithm. First, it identifies the first step by finding the lowest planar face with upward normal vector. Then we identify the ascent direction by finding the shortest line on the identified planar face. Finally, we determine the length by calculating the greatest distance between faces whose normals are aligned with the ascent direction. In real case, an incorrect manual measurement showed LE 285, while automation found LE 255. This 30 centimeters difference would have cost $30,000 in formwork modifications and was avoided. Now, some technical insights from our implementation. First, prioritize business impact over perfection. What I mean is extract valuable data from existing models instead of requiring perfection or standardization. Second, develop algorithms that handle model inconsistencies. And third, enable cross-project analysis because standardized metrics reveal opportunities invisible in isolated projects. And before I conclude, let me share our technical roadmap. So we will include data enrichment using Model Properties API this year, and in 26 with the Data Model API. Later this year, we will complete a develop to compare the raw structure of buildings with high accuracy. And in 26, we will execute our processes in the cloud through the Design Automation API. Thank you for your attention.